Every time you look up at the night sky, you see the exact same craters, the same dark patches. For thousands of years, humanity has stared at a single, unchanging face of the moon. When Galileo Galilei mapped the lunar surface in the early 1600s, it became clear that these distinct surface patterns never rotate out of view. If the moon is a spherical object actively orbiting Earth, different sides should naturally rotate into our line of sight. That is simply how orbiting bodies behave. Yet those hidden sides never appear. We assume the moon is motionless because it feels visually intuitive, but mathematically, an orbiting body remaining perfectly still from our perspective is a contradiction. To understand why, imagine walking in a circle around a table while keeping your body facing the exact same direction the entire time. If a sphere orbits without turning, a center observer sees every side, but if it constantly turns to face the center, the back remains hidden. The moon completes one orbit and one rotation in exactly 27.3 days. The very permanence that makes the moon appear completely frozen is actually absolute proof of perfect synchronized motion. Nature rarely creates perfect mathematical synchronization by accident, so what physical mechanism forced a massive celestial body into such a precise rhythm? Physicists like Pierre-Simon Laplace realize the answer lies in orbital mechanics. Gravity doesn't just pull, it exerts a physical torque, an invisible twisting force that actively acts upon the very structure of orbiting celestial bodies. Billions of years ago, the early moon was not yet completely rigid. It was significantly hotter, softer, and structurally malleable. This diagram illustrates what that malleability allowed. Earth's gravity pulled harder on the near side of the moon than the far side, stretching the sphere and creating physical extensions called tidal bulges. Because the early moon was physically deformed rather than perfectly rigid, it became permanently vulnerable to Earth's gravitational grip. If the moon rotated faster than its orbital speed, Earth's gravity catches the tidal bulge and tugs backward, breaking the rotation. Conversely, if rotating too slowly, gravity catches the lagging bulge, pulling forward to accelerate the spin. Over millions of years, this continuous gravitational torque drained the moon's rotational freedom, fine-tuning its spin until the periods matched perfectly. Once that match was achieved, the energy drain stabilized. The system reached a definitive state called tidal locking. The peaceful, calm appearance of the moon in the night sky masks the aftermath of a violent billion-year gravitational battle. The Earth-Moon system is not a unique local anomaly. This process is a universal gravitational law. The massive gravity of gas giants creates the exact same synchronized behavior, locking in the large moons of Jupiter. The effect can even be mutual. Pluto and its moon Charon are completely locked, permanently facing each other as they move through space. Beyond our solar system, worlds orbiting close to red dwarf stars face the exact same fate, resulting in entire hemispheres trapped in eternal daylight, while the opposite side freezes in endless night. Tidal locking forces chaotic, spinning beginnings into highly synchronized, stable structures. It acts as an essential organizing rhythm of the cosmos. This physical reality also debunks the myth of a permanent dark side of the moon. The far side experiences perfectly normal day and night cycles as it orbits. It is simply invisible from Earth. That invisibility finally shattered in 1959, when the Soviet Luna 3 mission photographed the hidden terrain, revealing alien crater patterns that no human had ever seen before. And the gravitational interaction works in both directions. The moon actively raises massive ocean tides here on Earth, and the friction from those tides slowly drains our planet's rotational energy too. This data visualization tracks the ongoing consequence. Earth's days are gradually lengthening over geological time, while the moon actively drifts away from us at a measurable rate of 3.8 centimeters per year. Billions of years of gravitational force have settled into this one perfectly synchronized orbital dance.